Hi, and welcome to another Palantir White video. My name is Ari Gordon-Schlossberg. I'm a senior software engineer and the author of the Palantir XML formats that we use for data interchange. So a couple sort of general points about building XML formats before we get into the details of the Palantir formats. We decided to use the XSD, the XML schema definition language. That's a W3 standard for how you do data definition in XML, because it let us leverage a lot of existing tools. So there's validators and editors that can do code completion for you. And there's other tools like XSLT that allow you to quickly and easily transform documents from one format to another. Additionally, when we sat back and looked at some of the existing XML standards out there, we saw that a lot of them were very inscrutable. You'd go and look at it, and clearly all the data was encoded there, but trying to figure out what was going on was like a tangled mess of references all over the place. So instead, we decided to design documents that were very easy to read by people, knowing that the computers could do it as well. So the first XML format I want to talk about is what we call Palantir XML, or PXML for short. And it's basically just a rendering of a Palantir object graph into XML. It's very sort of close to the metal format, to use a hardware metaphor. You'll see that sort of all the different concepts that are in PXML come directly from the way the object model works. Now, we're not going to go too deep into the object model, but we will do a little bit of a refresher. There are other Palantir White videos that cover our object model in depth, and I urge you to go check those out. So what do we use PXML for? It's used as an open import format. When we ship Palantir, it comes with a whole gamut of import tools that pull in about what we think 90% of the cases will be for import. For the other 10%, we wanted to design a format that other people could take their data and transform it to so that we can import it. So this lets us really pick up sort of the extra 10%. And it's not just something to be used outside the product, though. We use it internally, so our federated search server uses it to store search results and imported objects. And it's a very super efficient format that we use for certain types of long-term storage of Palantir object graphs. It's about an order of magnitude more efficient than Java object serialization, and about 2 orders of magnitude more efficient than Java long-term XML persistence. And the key thing here is that it's not just used for import, it's also used for export. We know that people are going to be building knowledge inside of Palantir, and they want to be able to get it out. And the way that you can do this is take an object graph, export it to Palantir XML, and be able to transform it using XSLT or other tools to bring into other environments. So Palantir DocXML is a very different beast. Rather than being a representation of the way that we hold data inside of Palantir, instead it's a container format for textual information, for unstructured data. So inside of it, you'll see things like the raw text, the source document, the results of entity extraction, the textual references to where those entities show up in the document, and some metadata about the document. So we authored this format, but it's really not inherently tied to what we do. It contains a bunch of optional features that make it easier to integrate with Palantir, but we expect that most people won't use those that often. And we've looked at the problem of extraction generally and decided that we shouldn't be tied to a single extractor. Instead, we can deal with any output of an entity extractor, and we already have spoken to multiple vendors who are supporting our format as a native output format. And again, following the Palantir design principles, it's designed to be really simple. If you look at the document, it's much easier to understand than other extraction formats. And you can take it and transform it from DocXML to another format if you'd like, or from another format to DocXML. So before we go any deeper, I do want to very quickly take a look at the object model just so that we have our terms together. You can see that there's at the center here we have an object, which in this case is a person who happens to be dressed just like me. And objects are connected to media, properties, and notes, which are our containers for data. Those actually hold the data that we store. Each one of those things in turn is tied to DSR's, data source records, which tie the data back to data sources. And any object can be linked to another object via an object-to-object link, and that also has DSRs that tie it back to data sources. And here's an example text document, and we'll be using this to sort of generate some test data that we use in some of our examples. This is just a simple recruiting report from a bunch of us on the road last fall. If we import this and properly tag it or run it through entity extraction, it looks like this inside of Palantir. If you put it on the graph, it looks something like this. I can take that graph in the application, select the nodes that I want, go to the investigation menu, choose export selected, and it'll create a PXML document for me. It'll export that graph to XML. And I want to encourage everyone to try this because it's the easiest way to get XML to sort of get some examples if you're not sure about how certain features should work. We export XML that you can always import again. So if you create the graph that you want, export it, you can always import it again and use that as an example. Before I dive into the excruciating details of each of the formats, I just want to cover sort of some general points of how to understand what we're doing. So we're going to look at the details and explanations of where to use them and give some examples, but A lot of the examples have been edited for brevity. So I've done things like shown some tags as singletons in this format. It doesn't mean that necessarily that they are singletons. Sometimes there might be one or more, and I'll be calling that out, but I wanted the diagrams to be simple and easy to read. We're not going to cover all of the features by any means. So take a look at the reference manuals and the XSD documents that actually define the formats to figure out what the exact details of every feature are. And finally, we will be covering most of the more important features, but there are certain esoteric features that won't even be mentioned. And again, the references are the place to look. So now let's take an in-depth look at Palantir XML or PXML. So the first question that we'd like to answer is, where do we want to use PXML? And the answer is fairly simple. It's to import and export. What do we want to import? We want to import data that doesn't import easily using the traditional tools that we ship with Palantir. So this might be things like data from a database where objects span tables, where you might have to do a join across one or more tables or other materialized views. And it's just kind of complicated to get it to materialize into a single view for import into Palantir. Or you might even have objects that span multiple databases. So there's no way to actually compose a single query that does this. Or even objects that span multiple different types of data sources. You want to take in media from a media server, as well as information from a database and other things from flat files. So rather than trying to compose that using the Palantir importer, which would be a bit complicated, we leave that to the information architects to be able to understand how they construct their real-world objects that they can then record into Palantir XML, and then we can import it seamlessly. On the other side, to export, you may want to take the data from Palantir and be able to export it to look at it in other analytical tools, other visualization tools, move it into other data platforms, or even into other Palantir instances. So PXML is very strongly tied to the Palantir object model, as I mentioned earlier. And the object model contains these things, data sources, objects, properties, notes, media, links, and data source records. And we see that the elements in PXML are actually very similar. You can see that they're named exactly the same way. And this goes along with that whole human readable aspect. An object is just in the object tab. With all that said, let's take a look at what the structure of a PXML document is. You can see that we start with a Palantir element that contains a graph element and then contains 4 sets of elements. People have asked, why do you start with a Palantir element? It seems almost extraneous when right here is the meat of the document. Why not get rid of these other 2 elements? Well, the idea here is that if you encapsulate everything inside a Palantir element, it allows you to be able to take this information and embed it inside of other documents and very clearly mark out which portion of the data is intended for Palantir or generated by Palantir as opposed to part of a larger document. The same is true of the graph element. Although these PXML documents that we're looking at are fairly simple, you can imagine a stream of XML data for Palantir that's actually made up of a graph element followed by a document element, which we'll see in docxml, and potentially other sections of data. So by doing this, we have a really nice encapsulation. We draw lines around what type of data that we're dealing with. Now, the meat of the PXML document are these 4 elements: ACL set, data source set, object set, and link set. We're not going to take a look at ACL set in this presentation. ACL set is how you apply all the different security operations to the data inside the PXML document, and that's actually a very complex topic. There's another Palantir White video on the security model, and the references can show how to do that. Rather than add that complication into what we're looking at today, we're going to leave that out, take a look at the reference manuals. We'll look at the meat of how we structure an object graph inside here. So before I explain the structure of the data source elements inside of a PXML document, there's an aspect of the way that data sources interact with Palantir document objects that I need to explain. So data sources inside Palantir are collections of references to data. They're a way to track pieces of data back to the data source that they came from. So they represent some real-world source of data, but they don't contain any data themselves inside of Palantir. They're just a collection of these references. Now, Palantir document objects do contain data. They contain the source of the text document or image or video or whatever it is that they're storing. So we have this notion of a primary object property that we can place onto a data source. And this allows us to tie the data source to the object in Palantir that contains its data. And so you see this used primarily with data sources that represent unstructured data. So things like Word documents, message traffic, emails, and any other source of unstructured text that you may end up with. So here we're looking at a quick example of how you encode data sources into PXML. You can see that there's an enclosing data source set tag, and that's just a way to containerize them all together. And then you'll have one or more data source tags. And a data source has an ID, which is referenced by data source records later on to refer back to this data source. It has a type, which is some sort of Palantir type URI. It's been abbreviated here with an ellipses just so it would fit on the screen. And it has a name, which is just the name of the document. Could be anything that you like. And optionally, as I mentioned before, has a primary object property. And this, you can see here, is an object reference to a Palantir object later on inside this XML document. So the second element, when I spoke of the meat of a PXML document, is an object set. And an object set contains objects. Now here's an overview of the structure of an object. We have a title property set, which contains the properties, media set, note set, which contain what you'd expect. I do want to call out title for a second, though. So it turns out title we've put in as a convenience feature. Inside objects, titles are actually stored as properties, so you'd expect them to maybe be in the property set. But we know that people deal with titles a lot. Either they're pulling in objects that just have titles, or when they export, they want to see the title very easily. So when we import, you can put information inside the title. We'll automatically generate the property for you. When we export, we take the property title and export it for you in the title tag, just to make it easier when dealing with things. So rather when you're dealing with titles, you don't want to have to go into what you'll see as a slightly complex structure inside of properties. It's available for you right away. So the place where all the structured data in an object is stored is inside of property. And here's an overview of what the property structure looks like. Each property is composed of a property value and a data source record set, which ties that data back to its data source. So property values can show up in one of three different ways inside XML documents: simple, composite, and raw. Simple and composite are actually two ways which we specify properties inside the object model. Raw is a convenience feature that we put into XML. So if we look at simple properties, they're used for unparsed data, things like nationality or the name of a company. They don't have any sort of smaller semantic subunits. Composite properties do have smaller semantic subunits. They're like an address, which is actually composed of city, state, zip, country, or a name which might have first, middle, last, and honorific. So let's take a look at the raw form. As I said before, we put it in here as a convenience feature to make life easier when composing XML and to deal with changes in ontologies over time. So the idea here with raw is that you know that the information is going to end up parsed out into what will eventually be a composite property. But instead of wanting to specify the composite property in all of its complexity, you've done the work to have custom parsers inside your ontology that know how to break that up for you. So this allows you to compose PXML documents that just put the raw value in there, and you use the ontology to break it up for you. This means you can change your ontology over time without having to change your PXML documents, and when you make changes to the way that you want to break up these formats, you do it in one place, which is in the ontology. Here we see the simple property value example. You have property, as we saw before, and the property inside the property value element is property data. And that's it. It's really that simple. There's a data source record set, which will tie this back, and there's a type URI which specifies what type this is. In this case, you can see nationality. A composite property value is a little bit more complex. Inside the property value tag, we have one or more property components which break out each one of the subcomponents of the property. So here we have my name. In the property data section for first name, we have Ari. For last name, we have Gordon Schlossberg. And using the exact same data for the raw value example, we see that instead of breaking it out into the separate pieces, this is a lot more like the simple case, where we just take the raw value, we throw it in a property raw value tag, and later on, the parser, as it's imported, will break it up into the proper pieces. So here's the media element, which, although it seems very long, is quite straightforward. We have an optional media title element, an optional media short description element, optional media description element, a non-optional metadata element, which contains the base64 encoded binary information that makes up this media. It could be anything from images to video to biometric information, anything that you can encode in a digital way. The thumbnail element is also optional, but it allows you to control how this media should show up inside the browser in Palantir. So for things like images, the thumbnail is pretty obvious, right? You just take the image, you shrink it down, you have a thumbnail. But for something like an audio file, it's not clear what you should use as the thumbnail. And if you know what picture best represents it, you can encode it here. Media ties back to its data source using data source record set, just like all the other containers for data. Note is probably the simplest of them all. It has an optional note title, the note data, which makes up the note, and again, data source records, which tie it back to its data source. So before we go into the structure of data source records, I just want to explain a little bit more in depth what they are and how they work. So data source records are those pointers that I was talking about that tie data back to their data source. They apply to all pieces of data, which is properties, notes, media, and links. And they have two different modes that they can be in. One is import keys. So import keys are used to tie data back to things that sort of have indexed or addressable data storage schemes. So databases, line-based files, structured XML documents with XML IDs, anything where you can come up with a small key that shows you where it came from in the data source. So for things that are unstructured, like textual documents, we use what are called string position locators. And these just mark where the references are by using offsets and lengths to show where exactly inside the data it came from. So here we see two examples of data source records. The first one is using the import key format. You can see that it refers to data source 1, and then it gives an import key of 23. Now, the import key is used to refer to the place in the data source that data source came from. So all data source records that have an import key of 23 refer to the same location. So that there is a uniqueness constraint here inside a single data source that anything with the same import key inside DS1 will be considered to be from the same place inside Palantir. If we look here at the string position locator format, you can see that we have a start position, end position, sentence number, and paragraph number. This is actually the reference to my name in that example document we saw. It starts at character 14. It's 21 characters long. I know it's a very long name. And it's in the first sentence and the first paragraph. And the final element that we'll cover are links. So links represent links between two objects. They're directed, meaning that there's always sort of a child and parent. Links go from a parent to a child. And we can do bidirectional links by having links in both directions. So here we see a link. It has an ID. It has a reference to the parent object, the child object, the type, which comes from the ontology, and the role. This can be like from or to in the case of things like payments or events. So we finished covering Palantir XML, and now let's take a look at Palantir Document XML. This is a format authored by Palantir, but it's not tied to Palantir. We've designed it as an open format. It does contain some optional features that allow it to tightly integrate with Palantir, but we won't cover them here. If you want to see those, please take a look at the XSD and reference documentation. We've baked in support for multiple entity extractors for each document. We know that entity extractors aren't perfect things, and sometimes you want to use more than one to get some agreement between them. So the object data sections, which we'll look at in depth, they're designed to be easier to transform targets from all the different XML formats that entity extractors output. And you can store multiple different object data sections in a single .xml instance document. Additionally, you can optionally store the output itself of the original extractor. So if later on you want to process it in some different way or see what the source document was for this markup, it's available inside the .xml document. Now, one of the neatest features of .xml is that it allows ontologies to change over time. Any particular .xml document is not tied to any ontology. In fact, Palantir instances use a flexible type mapping, which we'll also look at in depth, to figure out how to go from the type systems it finds inside a .xml document into the Palantir ontology that that instance is using. So what this means is that each .xml document is compatible with multiple Palantir instances out of the box without any changes, and that once you've created one of these, you should never have to change it. So one of the advanced features that we've included in .xml is very careful character set handling. We take the original documents, we encode them in a binary format and store them in the .xml instance document to preserve their original character set formatting. This way the source is always available to you in its pristine original form. We also UTF-8 encode the entire document so that we can deal with things like translated and multilingual documents without a problem. We've included support for flexible document metadata. We know that the end of the story with unstructured data is usually not found within the content itself, but some of the most interesting features is the metadata on the document. Where did it come from? Who produced it? What path did it take to get to this Palantir instance? So not knowing what those should be ahead of time, we've made sure that that's a completely flexible system. You can specify your own type system for the properties that you'd like to have appear, and then map them into the document objects in Palantir so that when you look at them in the browser, those properties are available to any analyst who wants to look at them. And finally, following the Palantir design principles, we've made it very easy to understand and transform into different formats. We've made it XSLT friendly by making sure that all relevant information is contained in the same portion of the document. We've put places to hold the extractor configuration inside the document, so later on if you want to re-extract or understand what settings were used to create the object data, it's there available for you. And we see this as maybe being used as sort of an intermediate format for a multi-step extraction. If you want to run it through 5 extractors, you can use .xml as the intermediate format as it moves through some sort of extraction pipeline. And this gives you a single interface for the ingestion of extracted documents, both going into Palantir or coming out of Palantir, or not being used with Palantir at all. You could take this and use it as a long-term storage format for just some sort of repository of extracted documents. So let's take a look at the overview of a .xml document. Just like with PXML, we start with a Palantir element. Inside of it, we have a document element. And then we have these 3 sections, which is document metadata, information about the document itself, the content of the document, the original, followed by 1 or more object data sections that correspond to each entity extractor used on this document. Taking a look at the document metadata section, we see that we have many different elements here. Some of them are optional, some are required. We have title, source, which may be the place where the document came from, like file name, URL, or some other sourcing mechanism. The content type, what do we expect to find in the document, like text plain, text HTML, or application MS Word. The encoding, what character set the document uses, the timestamp of when it arrived or when it came into the system. And then we have a document properties section, which I alluded to earlier, where we have one or more properties that are basically just name value pairs to attach to the document. We'll use the type mapping later on to decide how those should come into Palantir. And finally, optionally, we have sentence breaks and paragraph breaks. If you have this information available on the outside and want to canonicalize it, you can do that here. If not, as it comes into Palantir, we'll calculate it using our algorithms to do so. So here's an example document metadata that I might have produced for the document that we were looking at earlier. Its title is Recruiting Report. The source is the file recruitingtripreport.txt, content type text plain, encoding UTF-8, and the timestamp of when it was written. Here's an overview of the object data section. Each object data section contains object set metadata, which explains what we're going to find in this section, a set of objects that have been extracted, and an optional set of relationships which link one or more objects to each other. Looking at the object set metadata element, we see that it has an external ID. This is how we hook these things up to the type mapping, which we'll look at a little bit later. A description section, which holds a human readable description of the information held by this object data section. External metadata, which is a binary encoded field where you might store things like the configuration of the entity extractor for later use, and the original document if you'd like. This is a place where we envision storing the actual output of the entity extractor that was used to create the object data section. Here's an example of the object set metadata section. Here we have an external ID, ACME, which we'll come back to later, which uniquely identifies the type system that we're using. This is a tag that you apply to each entity extractor type system. Here's a description, the ACME entity extractor. And here's the optional external metadata section where we might keep the configuration of how we ran the ACME entity extractor. And here we might put the original document, again, base64 encoded so that any sort of data can be placed there. So inside the object set element, we have one or more object elements that represent objects that were noticed by the entity extractor. And they have a type, and they have an ID, and a title. Entity extractors love putting titles on things. And then one or more text references that show where it showed up in the text. And these are specified by the offset, the length of the reference, and what property these should have. So here's an example of my name from the original document that we were looking at. You can see the extractors decided that the title should be Ari Gordon Schlossberg. The type is person name, which corresponds to the type system used in the ACME document extractor. And here's an ID, arbitrary ID for the object. The reference, again, starts at character 14. It's 21 characters long and has type person name as well. And then here's the value of that reference itself, Ari Gordon Schlossberg. We see a second reference, which has a much deeper offset into the document, a length of only 3 with the same type, and its value is Ari, just my first name. And you can see that the entity extractor here has decided that these are 2 references to the same object. Relationship is probably the simplest element in all of docxml. Again, it has a child, a parent reference, and a potential type, and it just links 2 objects together. The content of these references will be the IDs that we've seen in the previous slide, so obj1, obj2, that sort of thing. Before we go into the structure of the schema mapping document and how you specify the flexible type mappings, I'd like to go over a few pieces of information about how we do this. So, as I've said earlier, docxml documents are not tied to an ontology. Each single document can be ingested into many different Palantir ontologies. Changes in ontology don't require re-extraction or changes to the original document. You just change the flexible type mapping. And each document can use multiple mappings, one for each different extractor that's inside the document. So the mappings that we're going to define, they map extractor types and document properties into Palantir ontologies. So they'll see there's a separate mapping section for each supported extractor that this Palantir instance knows about. And the document properties map the properties that we saw in the document metadata section into properties that will show up on the document object inside of Palantir. Now, this is a centrally managed resource for each enterprise deployment of Palantir. It's not something that analysts specify on the fly. The information architects or the Palantir administrators sit down and figure out how this entity extractor should map into the ontology that this enterprise has decided to use. And this way, as an analyst, the imports just seamlessly work. You just take a docxml document, it comes in, and everyone uses a consistent mapping, and there's a central place to make changes. So here's an overview of a mapping document. You can see that it's all contained in a mapping element, and it contains a document property mapping element, whose structure we'll look at in a second, which maps the document properties, and then one or more mapping contexts, which contain an external ID. If you recall, we saw this same attribute on the object metadata section for each object data section, and this is how these two tie together. So the document property mapping section just has one or more property mappings, which take a name, which is the name side of those name value pairs that we specified earlier, and maps it into a Palantir property type. So every document property that has this name will end up being this Palantir property type on the document object. Let's take a look at the mapping context element. Each mapping context element has an external ID, which is how we relate this to the object data section that we find in a docxml instance document. And then it contains one or more type mapping entries, which map an external type, like person name, to a Palantir object type, property type, or link type as appropriate. Each one of these is optional, and we can specify 1, 2, or 3 of these. Here's an example of the mapping context. Going back to our earlier examples that we saw of the instance documents, you can see that we're using the Acme entity extractor. And if you recall, when it recognized my name in the document, it marked it as type person name. In this type mapping, we're saying that person name, a type from the Acme type system, should be mapped to the object type person in Palantir and the property type name. What this means is that as we import this document, an object will be created with type person with property name Ari Gordon Schlossberg. You can see here are two other mappings that might show up here. Org name might be something else from the Acme type system, and in that case, we want to create an organization object with an organization name for its property. And here we see manager of, which doesn't have a mapping to object type or property type, but does have a mapping to link type, which it'll create a link type of type supervisor of. So that's the end of our in-depth look at docxml and Palantir XML. I'd like to leave you with a couple thoughts of how to digest this information before I finish. This presentation is designed as an overview of these two formats. Both pxml and docxml have features that aren't covered in this presentation. The XSD files and the documentation that ships with Palantir are the canonical reference for these two formats. The full syntax and rules of how they're used are covered there, and you should consult them to get more in-depth explanations of use cases and exactly how to use different features. Both of these are living standards. We guarantee that they'll continue to be backwards compatible into the future, so that a docxml document that you make today, you'll be able to import 1, 5, or 10 years from now. But we may add new features as time goes on to meet customer needs or as we imagine new use cases that we think can push forward the state of the art. And finally, in building these XML formats and implementing them for the Palantir platform, we've learned a lot about how to do high-performance XML processing in Java. We've recorded some of these thoughts in some posts on our blog. I would encourage you to go check out our blog at blog.palantirtech.com to see some tricks and techniques on how to do XML processing. I hope you've enjoyed this talk. I'm Ari Gordon Schlossberg, Senior Software Engineer here at Palantir Technologies. I hope you enjoy the rest of the videos.